Okay, I think we're good, guys. I had to delete a bunch of files that I previously downloaded, and I think that was causing the slowdowns in VS Code on Ubuntu. Now it looks like it's better. Let me wait for people to rejoin, for those who were there. Okay. While people are joining, let me just go quickly grab a glass of water. We'll be back in a minute. We'll be back in 30 seconds. Okay, I'm back. Let's go, guys. Let's bar the arguments. There is some issue here. Let's see what's up. I love these messages when there is like zero information what happened or where it failed. And it's like arg parse, standard library in Python. Guys don't know how to write error messages. Okay, base directory, corpus. Again, let me compare. Let me open up the task xsim eval script. Here is the eval script. Here is how the eval should be called, base directory. Okay, and then there is the path, and there is the corpus value, and then there's the corpus part. And I did set the dev test there, and then margin ratio, source encoder, and then a path to source encoder, and then source SPM model, and then we pass the SPM model, and finally source languages, and then envy verbose. Okay, everything looks okay, if you ask me. Let's just see, maybe the, I don't know, maybe there's some required argument that they've missed. Base there, corpus part, and source encoder. One, two, three, source encoder, source langs, and this is not required. Required true. We have 5 required arguments, and we specified all of them. And this is just going to be a string, I assume. So source langs is going to be, yeah. So it should literally be just a string separated by a comma separated string. Let's see. Why is this not working? What is exactly failing? As all of this looks good to me. Does anybody recognize any error here? I don't know, it looks good to me. Did they specify the right config? Okay, I did. And then if I run it, Okay, no, wait. It's failing somewhere here. How can I figure out where it's failing? Okay. Let's just start and analyze every single argument. So this is just a path. Corpus is just a string. Oh, okay. I see. I omitted double dashes here. Margin, this is okay. This is bad. Double dash, double dash. This should work now. Let's see. Oh, I even got the, okay. I got the error message here though. Error, the following arguments are required. And again, the slowdown for some reason in VS Code. Is anybody using VS Code on Ubuntu? And do you have problems with speed in general? I did delete many directories and datasets I downloaded before. By the way, this weird white triangle is just sunlight from the green screen, if you're wondering. Slow, super slow. Let's see whether I can delete some more data. Git ignore. Invalid syntax. I'm not running git ignore, man. I'm running eval. Okay, we solved it. It was just a double dash syntax error. Okay, let's go eval here. So it just stores a bunch of these arguments and then loads a model here. So it loads a source self-encoder args. Let's see whether we have anything here, or is it just an empty dictionary? Okay, we have a couple of arguments there. Then we load the model. We just load the sentence encoder. And then that's it. That's the eval. Let's continue. We create a temporary directory. And then we sort the languages here. And then we sort these ones. It's going to be an empty list. And then we call the xsim n-way parallel. We create a zero matrix shape 6 by 6 because we'll be doing comparison between each of the languages. So let's see how that's gonna look like. So now we do some embedding using the SPM model and the embedding directory here. So let's see how that looks like. Let me just put a breakpoint there. Okay, so for each of the languages, we're going to do the following. We grab the language name followed by the split. If we take a look at Flores here, that's exactly how these files are named. So we go base directory, which is basically data, and then we go to Flores, and then we go to split, which is gonna be dev test, and then we go and grab the name. So that's one of these files here. We assert it exists, and then if the language is in target languages, we do some but we're skipping this. This is for xsim++, and then we just embed the sentences. Okay, we embed the sentences, and then embed data, language, input file, output file, augmented JSON. Nothing happens there. Embed sentences. Okay, this guy just, okay, we are familiar with this method already. So we can just skip. This is gonna just embed stuff. And then, so we encoded 1012 sentences, assert that the output file exists. It's in the temporary directory, and then we just append. And we repeat these for all of the languages, and we are done. Okay, cool. So now, let's see what we do now. We go through all of this data, and we go, so we do a double for loop. If it's the same language, then by definition the error is 0. Otherwise, we go and call the xsim method. And then after this, finally, we just create a pandas data frame. We find the average, and then we just display the data here. That's it. So this is the main logic, xsim. So let's go there, and then, so here are the embeddings. Here is the margin, here is the dimension. Are we comparing indices? We are not. Okay, let's just go to xsim. Margin has value. All good there. If it's instance of numpy array, then we go and we load. Okay, we just go and load data. We load embeddings from this input file, and we'll have 1012 as expected. We resize so that the shape is 1012 by 1024, and we return that. And we do the same thing for the other file. So these are the two languages now, so we have their embeddings. And so now finally, let's see how the xsim is calculated. So this is going to be calculate error. This is where the magic happens. So we go and call score KNN. Okay, let's see what's up here. We find the closest neighbor. So for each x, we calculate the highest scoring neighbor from y. Fair enough. So then expectations, that means that this output matrix is going to be 1012 by 4, because basically for each of the input embeddings we find 4 candidates using the ratio margin. Okay, let's quickly open up this one. 1012, 1024. We create two indices. We normalize the embeddings, then we add the embeddings, and then we go and search. So find the k closest neighbors, and you can see here this is 1012 times 4 as expected. Okay, this is just standard stuff. We've seen this code before already. And then we do score margin. So this is a bit more complicated logic here, but like ultimately we just end up with some scores. So we can skip this. And finally we find the argmax to find the best indices. And it's always 0. That's weird. Indices and then index XY. We find the best one. Okay. Let's see how these look like. It seems they're perfectly sorted. Well, okay, yeah, that makes sense because it's basically n parallel corpus, and that's the whole point, right? So the expectation is to get 0th sentence aligns with 0th sentence, first one with first one, second one with second one. So that's completely expected. And now we return the indices. Let's see whether this is okay. This is some path. English, Latin. What's eval text? Let me just go back here for a second. Let me go back here. So we passed the target txt there. Okay. Target language. Target text is English. And the input text is what? Okay, got it. English. Afrikaans is probably the first one. Yeah. Okay, makes sense. Let's go back here. So we open up those lines, and then if that's different than if we grab the closest neighbor to this guy, if that's different, then we have an error. Got it. Okay, makes sense. And then we just return those values. So we have 0 errors for this particular language direction. Zero errors. And this is how we compute the error. Okay, makes sense. I now completely understand what's going on here. So xsim, like cross similarity or whatnot, what it stands for, something like that. We can remove now all of the breakpoints, and let's just print the matrix and see the results. And so the results look something like this. Let's quickly take a screen capture. Take a screen capture of this and compare it with expected value in the README. I think this should be the correct result. Oh my god. Nice. 058. And the README expectation was, if we go to tasks, xsim, README, let's open the human readable version. Why are you not working? This document is in an invalid state. Okay, let's just open it up in a raw format. And I don't see the expected results, but I guess that's it. Cool. Okay, guys. Let me go back here. We are done with the tasks in Laser. So now let's see whether we want to train the checkpoints in FairSec or in GPT-NeoX. Let me send a couple of messages here. Okay. Somebody wrote a message in the chat. Let me reply to that. Anish, hey, what is happening? No, we just went through the various tasks in Laser database, which is meant to do bytetext mining for NLLB. And now we are about to start figuring out how to start training the checkpoints. So I'm thinking whether we should go and use FairSec, because that's where the default implementation lies in. Although the thing is, the NLLB branch is like 1 year old, so we might be hitting various issues. GPT-NeoX is better supported, but on the con side, we'll have to re-implement some things. I'm currently in Belgrade. I'll be going to Shanghai for some business trip for like 7 days in a month, like maybe around 20th of September. Miss Pidis. Okay. Does anyone from you guys have experience with GPT-NeoX or FairSec? Let me know in the comments. I'm going to now write a message on Discord asking people what's a good place to ask this? General as well. Let's open up GPT-NeoX. I think we should spend some time analyzing the code base. And let's maybe ask a question on Twitter as well. Any other frameworks I'm missing out on? What else do people use? GPT-NeoX basically uses Megatron and Deep Speed in the background, so that's kind of covered by them. Fairsec. There is some framework from Google probably. Let's check out GPT-NeoX. Okay, Anish, I won't be focusing on those beginner questions. I think it's better to go to Discord and just ask questions there, or check out my blogs. I want to focus on a bit more hardcore stuff here. So it does require some knowledge of what I'm going to do here. Okay. Version 1. Snapshots of the old. Let me just lower down the shaders. Too much light. Okay. Quick start. Python 3.8. Okay. To install the remaining basic dependencies, run VenDB, weights and biases, TensorBoard. Optional if not using fused kernels. Okay. Deeper speed. Flash attention. Install the additional dependencies under there. Okay. Accordingly, see the configs. Yeah, let's take some time to analyze GPT-NeoX today, and then we can make a educated decision on how to go forward to train the NLLB model. By the way, if you don't know what flash attention is, I wrote a nice blog on the topic. Flash attention, I think it's first. Yeah, it's literally first on Google search. Among the first results here. You can check it out. Fairly detailed. step by step how it works, and even some notes I've written down. They also have a Docker file if we want to run it in a Docker container. They also have pre-built images. Okay. You can then run a container based on this image. For instance, the below snippet mount the cloned repo and uses NVIDIA Docker to make 4 GPUs accessible. Okay. Fair enough. They offer 3 main functions: train, evaluate, using the LM evaluation harness, and generate is used to sample text from a trained model. Okay, which can be launched by calling the dpy and then some configs. Or optionally passing a text file. To use as the prompt, which would be a plain txt file with each prompt separated by new line characters, also passing in the path to an output file. Okay, you can generate, you set up the configuration here, and then you do the prompting. And output here. Yeah, we're gonna try and set everything up, and then we can run a couple of these examples, load some of these big neural networks, and see how it works on my 2 GPUs. Curious to see a bit more how this works, because I did play with FairSec already, both with training and fine-tuning and inference. So I will be able, there's probably not that many people who've been using both frameworks. The documentation looks very nice so far. That's very encouraging. Okay, we can see the training here. Okay, let's kind of skim through the rest of it. Configuration, defining YAML. I think that's I've opened up that one here. Okay, we might need to change pipeline parallelism settings and model parallelism settings to increase or decrease the degree of parallelization, train micro batch size per GPU or gradient accumulation steps, to modify batch size related settings, or to 0 to modify how optimizer states are parallelized across workers. See the configuration README. And for arguments, you can check out this one. Cool. NeoX arguments. Okay. Several pre-configured datasets are available, including most components from the pile, as well as the pile train set itself. For straightforward tokenization using the prepared data entry point. Okay. To download and tokenize the NVIC8 dataset with the GPT-2 tokenizer, saving them to data, you can run this. Got it. The tokenized data will be saved in 2 files. You will need to add the prefix that both these files share to your training configuration file under the data path. Okay. Using custom data. Formatted as one large JSON-L formatted file, with each item in the list of dictionaries being a separate document. Okay. You can now pre-tokenize your data using the pre-processed data by the arguments of which are detailed below. Okay, we can check out the details a bit later. For example, you would then run training with the following settings added to your configuration file. Okay, training is launched using DP. How do you read this? DP. A wraparound deep speeds launcher, which launches the same script in parallel across many GPUs/nodes. They will be merged at runtime. Okay, then I guess it makes more sense to just create a dedicated config. You can also optionally pass in a config prefix, which will assume all your configs are in the same folder and append that prefix to their path. With 1 process per GPU. This will deploy the train by script on all nodes with 1 process per GPU. The worker nodes and number of GPUs are specified in the job host file. or can simply be passed in as the number of GPU's arcs if running on a single node setup. Not strictly necessary. We find it useful to define the model parameters in one config file and the data path parameters in another. Okay. Pre-trained models. I think I read a paper before. I might have even covered it on YouTube. Did I? Yeah, I did. Check out this video if you don't know anything about GPT-NeoX. The configuration file for this model is both available at configs20bml and included in the download links below. Okay. Trained on 96 40GB A100 GPUs. And included in the download links below. For inference or fine-tuning, 40GB. Cut directories. This probably just shards the checkpoint or whatnot. Let me just quickly double check. Ignore the first 5 directory components when creating local directories. You will exclude the first 5 levels of directory structure from the URL. Nice. Full weights, including the optimizer states, 268GB. Nice. Torrent files can be downloaded here. I recently read the Pythia paper as well. Polyglot project. Interesting. This is similar to what I'm trying to do in a way. Is an effort to train powerful non-English pre-trained language models to promote the accessibility of this technology to researchers outside the dominant powerhouses. Has trained and released Korean models, the largest of which outperforms all other. No, this is not NLLB. This is just a large language model for a different language. Can be found here. That's interesting. I'm gonna check out that work in a second. Hugging Face is better optimized for inference. We support 3 types of generation: unconditional, conditional based on input read from a file, interactive, which allows for multiple runs of back and forth between the user and the language model via command line interface. All of them can be launched using the generate script. Okay. Okay, they support weights and biases. Okay, this is Apache 2 license. Cool, guys. Looking nice. Let's quickly skim through this. Let me see what are some of the pain points here. Llama, of course. Fine-tuning 20B doesn't seem to work. Okay. I'm gonna soon, let's download and play with this. So the next step will be to analyze, set up and run some examples. So set up GPT-NeoX. And then run some examples to get familiar with the code base. Just writing down some tasks here. So let me return this back here. Let's just see what this polyglot project is about. I'm curious to hear a bit more about the problems people are facing here. That's gonna be fun. Very relevant. They didn't share the actual data. Okay. This guy has quotation mark around his own question. Fun. Okay. Let's read through the README. What's the license behind this one? Apache 2 as well. Bloom X GLM have been released. Therefore, someone might ask, why do we need to make multilingual models again? I'd like to ask, why do people around the world make monolingual models in their language even though they are We have already had 1.2 terabytes of Korean data collected by Tunip. Who are these guys? Nice. Okay, weights and biases. Got it. Model cards. A series of large-scale Korean autoregressive models Let's see what the community says. Okay, let's see the model card. The model consists of 24 transformer layers with a model dimension of 2048, blah blah blah, rotary positioning, embeddings, rope is used, and it was trained on 863 gigabytes, 1.2 terabytes before processing. Has abided by South Korean laws, so it will not be released for public use. Huh, interesting. Let me ask some Eleutherii folks about this tunib. About this tunib dataset. Okay. Trained on 213 billion tokens on 256 A100 GPUs. Interesting. Brain, those guys are from South Korea. I remember seeing them at ICCV back in 2019. The following tables show the results when the number of few shot example differ. For a fair comparison, all models were run under the same conditions and using the same prompts. Let's see the results. Okay, they definitely have the best results. Same here. Nice, nice. Is this this is error or what? Okay, whatever. Licensing. A large-scale Korean dataset for this work. Nice. This is fun. Very cool project. Polyglot. And the checkpoints are apparently available. Here are the checkpoints. Technical report. I'd love to read this paper. We can maybe do this in the next stream today. I see a lot of Korean names here. Okay. Japanese stable LM. We co-worked with Stability AI Japan to create open source Japanese language models. We mainly contributed the dataset collection part for this project. Blog post here. Let's check out this project as well. I would really love to create such a language for Serbian language. Such a model for Serbian language. My brain is not working anymore, guys. For Serbian and other languages as well, but I want to focus first on machine translation. Polyglot has been trained to optimize next token prediction. Awesome. This is truly amazing. I love it. Okay. So, because my brain is almost fried, let's first just play with the repo, set it up. That requires less cognitive effort, and then later in the next stream we're gonna read through the Polyglot Korean paper, and we're gonna go through the Japanese language model as well. If that makes sense, guys. Okay. Let's quickly skim through this config readme, and then we can download the GPT-NeoX and start playing a bit with it. Below is an example configuration to train a 160 million parameter GPT model. This README will go through each section in the configuration and the options available. To see all arguments here, go here. Okay. Again, for these zero optimizations and stuff, I also covered some of them in my YouTube videos. You can check them on my YouTube channel. If you go here, did I just see myself here? Yeah. Okay, let's go here, and then you have, I think Megatron. Was it Megatron or something? Megatron, LM, and Zero. So in this video, I've covered all of these techniques for how these systems are trained. You can check it out. Atom optimizer and CPU, either Megatron's version or Torch's. SM3 memory adaptive efficient optimization optimizer. Doesn't work well with FP16. Madgrad. zero optimization. Okay. Our global batch size configuration follows deep speeds and can be configured in a number of ways. Effective training batch size. This is the amount of data samples that leads to one step of model update. Number of training steps to accumulate before averaging and applying them. Okay. If you're running on Slurm and wish to use Slurm to coordinate nodes, then you must set the following variables. Okay? I do have Slurm set up on my Ubuntu. I've done that because of an NLLB project. So some of the scripts required Slurm, otherwise it would be failing, so I set it up. Took some time. To make this JSON, just remove the comments and use the all lowercase for the boolean. Okay, fair enough. Let's download this. Okay. Cloning. Okay guys, let me open up the VS Code, and let's actually open up one more window. So new window here, and then open, oops, what's going on? Open folder, and then go to projects, NLLB, and then GPT-NeoX. Okay, we are here. Has anyone played with GPT-NeoX from you guys? Let me know. Let's quickly skim what's going on here. Megatron. Fused kernels. A ton of requirements. Tests, tools for conversions. This is the main launch script. Docker file. What's this? Maximal update parameterization. Okay. Greg Yang made this project, I remember. He's now at XAI, by the way. New Elon Musk's company. Okay, we can close this. Why is this VS Code so broken on Ubuntu? Are they actually using this? Okay, readme to install. Okay, guys, let's do conduct read GPT-NeoX, and then Python 3.8. Yes. Conda activate GPT-NeoX. Let's see what else we need to set up. First, make sure you're in an environment with Python 3.8 with an appropriate version of PyTorch 1.8 or later installed. Note, some of the libraries that GPT-NeoX depends on have not been updated to be compatible with Python 3.10, blah blah blah. Okay. To install the remaining basic dependencies, run all of these. Okay, let's install PyTorch 1.8 or later. Wait, what's the latest version of PyTorch before 2.0? 1.10, 1.11, 1.12. And then 1.13. And finally 2.0. Okay, so Torch 1.13. Is there any CUDA requirements from their side here? No. Well then, let's just run one of these. Basically the newest non 2.0 version. Install PyTorch. Okay. Let me just see whether I'm getting some messages. Okay, we're still waiting for this to download. Okay, done. Now let's go and let's install these. So requirements, pip install requirements. Let's just see what those are. Maybe we can split this. Best download, Hugging Face, large model eval. Okay, let's just run this. Errors. Something failed. What exactly failed? Let's see. this. MPI. Include MPI failed. Cannot compile MPI programs. Check your configuration. Could not build wheels for MPI for Python, which is required to install PyProject NLLB projects. Failed to build MPI. Let's see whether somebody's hitting similar issues on their code base. Same issue with MPI. Try installing libopenMPI-dev, something like this should work, and then try again. Okay. This is a soft requirement that we haven't gotten around to handling more elegantly. If you're planning on using the Torch distributed NCCL backend, which you probably should be, then you can delete this package requirement without breaking anything. Okay, let's just do this for now, because we already tried installing it. Rerunning the command again. Looking good so far. Okay, nice, it worked. So that was the solution. Okay, let's continue. Next up, we need to install weights and biases for logging. Okay. Next up, we need to install TensorBoard. I'm not sure whether I'll be hitting some import issues if I don't install everything, so let's just install this. And then optional if not using fused kernels. Again, let's just install all of this. The detected CUDA version mismatches the version that was used to compile PyTorch. Please make sure to use the same CUDA versions. Okay, I guess my system has I installed CUDA 12.2 system-wise, yet here we have 11.7. Why can't you just reuse my local environment CUDA? Huh. Okay, we can ignore this for now. Let's just note that somewhere that we didn't do that. Okay. Fair enough. And we should be good now. Okay, let's now try and run let's see what's up here. Why is VS Code complaining constantly? Okay, finally working. VS Code is just very unstable on Ubuntu. Okay, let's see what next. Let's just try and run something. Maybe. I'll be wrapping up the stream soon, guys, by the way. Maybe 20-ish more minutes and then 2-hour break, and then I'll continue later. We can read the paper and we can read the blog. Until then, let's see whether we can run something here. Let's run some small checkpoint. Okay, let's just try and run the generate script with some smaller model. Okay. Let's use some smaller model than 20B apparently. Failed to find the Go binary in either Go root or path. I'm not using Go, man. Okay. Let's set the interpreter here. Let's set it to GPT-NeoX. And now let's run this. But before that, let's quickly change the config. We don't want a 20B config. I can't run that on my machine. As as far as I know, you need more than 2 GPUs, even for generation, right? 40 gigabytes files. We might be able to run it. Let's just double check that. But either way, if there is a smaller model, let's use a smaller one. So 20B. Okay, maybe we can take the 1.3B. That would be cool. There are some even smaller models here. 90M. Let's just run something like this. Okay, so 350M. That sounds good. And let's try and run this. So this should work. Okay. Let's see how this looks like. If we manage to run some unconditional generation using this small checkpoint, that's a good first step to analyze the GPT-NeoX codebase. Okay. Consume dpy args. What exactly that one does? Does it grab the hopefully it took the values from the config that I've chosen, which is this one. Number of layers. Let's see whether there is number of layers or something like that. Number of samples, nodes, GPUs. That's still not set. Okay, let's just continue, and then we'll see if it crashes. Get the key. I don't have it. And then just launch, and then it should start this script. Go to main here. Okay, let's see what happens. Okay, we are in the generate script. Nice. So far it's promising. No description. Woke-up file is none. We probably have to download the GPT-2 tokenizer or something. I think I've seen that in the README before. So let's see whether that's the case indeed. Do you guys hear me well, by the way? Or am I just talking for myself? Which helps, actually. How did we get here? Tokenizer. Megatron. Main. Aha, got it. So we failed here, basically. Okay. Let's see. Let's rerun this. We will probably need to download the tokenizer. So tokenizer. Make sure to download the GPT-2 tokenizer vocab and merge files from the following links, or use the 20B tokenizer. Okay. Well, let's download these two then. Okay, save the vocab and save the merges, and then we can just copy these two guys. So let's go here and we can just copy from downloads GPT vocab, copy it here. We should now see it somewhere here. Okay, I see it. And then we also need to download the merges. So GPT-2 merges txt here as well. Couldn't find it. Wait, why? Okay, because it's called S3. So let's do the same thing again, but this time S3 something, and then copy it here. Okay, looking good. So we have those two tokenizers. Is there anything else here in the... I don't think so. There is the 20B one, but we don't want to use that one. So let's go back here and let's see why this is failing. So we can just rerun. Let's just rerun the dpy. I don't even know how to pronounce this. Let's just stop the process. Let's rerun the dpy. Okay. And we are back here. Let's enter. Let's see whether something's gonna fail here. Okay, that guy fails. Apparently. Vocab file is none. Huh. Wait, do I have to set something like that? Why didn't they mention that anywhere? Vocab file, if we go here, oops. Again, VS Code just keeps on dying on Ubuntu. It's just terrible piece of garbage. Local setup. We probably have to pass in local setup or something. Let's do it like this. Okay, let's save the GPT-2 to data directory. So let's create one if there is none. Let's just create a data directory. Configs, VS Code, Megatron, requirements, tests. Okay, let's go here and let's create. So there is no data as far as I can tell. Data. Nope. So let's make directory called data. Let's basically copy GPT-2 vocab to data. Let's copy the S3 to data. Data. Let's now remove GPT-2. Let's remove the S3. Let's change directory to data. Let's rename them. So we have GPT-2 vocab, that's cool, and then we have to move S3 to GPT-2 merges txt. Okay, so we are good now. We have vocab JSON and we have merges txt. Okay, and then let's just see local setup. Is anything mentioned in the README here? Local setup. It is. They're mentioning setup. Okay, so we have to call local setup here, I think. Okay, fair enough. Fair enough. Let's just pass. We need to pass local setup. Let's do it like this. Generate launch JSON. Where is my launch file? Here it is. So generate, and then let's go and do the following. So 350 M, remember that. So we need or 125 works as well, whatever. Local setup. Okay. Text generation. We should be good there. Let's just see whether there is something additional we need to take care of. 125 M. Is that the config we were using, right? Config 125 M. Okay. Is there anything special here? Number of layers hidden. Number of attention cats. Layer norm rotary, all good there. Column. Init, atom, 0, we don't care about those because this is for training. Regularization, precision, enabled, logging, host file, we don't care about host file for now because we won't be running this in multi-node setup. We're just trying this on a single node, i.e. my rig with 2 GPUs. So let's see. Let's go back to launch. That looks good. Let's see the local setup config. The local setup config has this, and we did set this. That's cool. Save and load to checkpoints. That's good. VenDB host API, VenDB AI, all good there. And VenDB project. Let's just say something like Ortis. Okay. And then the last one is text generation YAML. Here it is. Unconditional, maximum tokens 102, and on new lines, temperature 1, top PK, all good, recompute, looking good. Sample input file. Sample input, sample output. Okay. Does this mean we have to pass in? Well, if it's unconditional, then why sample input? Okay, let's just try and run this and see whether this causes us any troubles once we start running. We can close down this. We can close down this as well. Arguments. Let's run dpy again. Okay. Nice. So, if I just step over, will it work? Initializing Torch backend in deep speed with backend NCCL. NCCL backend in deep speed is not yet implemented. Okay. What's going on? Will this work or will this fail? Guys, anyone who's listening to the live stream, are you using VS Code on Ubuntu yourself? Let me know. And are you having any issues with slow execution? It seems it's glitching. I've never really used it intensively in Ubuntu. Usually I just use Windows. And I never had any issues there. It's just not working. Or I didn't click F10. Oh my god. Okay, this time I'm just stupid. Okay, now we have different. We now have a different error. Configure zero optimizer. Zero stage 1 requires an optimizer. Where is zero defined here? Stage 1. Why? We don't need this. Let's just set this to 0. And let's rerun it. Just stop the process and rerun it. Okay. Let's see. Nice, it worked. Awesome, guys. So yeah, for some reason the default setting is that zero stage 1 is enabled, which we don't need when we are running a model that has only 125 million parameters, so it doesn't seem like a reasonable setting. Recompute is set to false. Not exactly sure what they mean by recompute in this context. So if it's unconditional, it is, then we just print to sample output txt. Where is that file? Is it gonna be in the root? Or just, let's see, let's just run the find command for a second. Maybe any file that has txt. Okay, and then it says what? I don't see. I see the standard error under logs. I don't see the sample output. Sample output is not here. Nope. Okay, we're gonna figure out things along the way. Generate samples unconditional. Interactive. Okay, so this is the main script. We pass in the model pipeline engine. Is it? Hopefully pipeline is set to 0 or 1. Okay, 1 means probably just a single GPU. That's fine. All looking good there. Looking good there. Let's go back to the breakpoint. Number of samples 10. Output there, maximum tokens, recompute false, temperature 1, all of that is, I've seen that. GPT-NeoX args. Okay, let's just enter here. Samples unconditionally, no prompt, and yields them in a dictionary. Okay, a Megatron model. Let's go there. Generate samples unconditional setting. Okay, it says unable to find latest file at checkpoints latest. If trying to load latest checkpoint, please ensure that this file exists or pass an explicit checkpoint tag when loading a checkpoint. Okay. Some errors here. Or no, just in red for some reason. Okay. Let's go. Generate samples from prompt, and prompt is probably just empty, right? Because, yeah, okay, we just pass an empty list of 10 empty strings. List with 10 empty strings, makes sense. Fairly intuitive framework. I like it so much more than Fairsec. That much is for sure. Although Fairsec is much more like a Swiss Army knife or something compared to this repo. This is mostly for training just large language models, to the best of my knowledge. They don't train anything else. Okay, let's see. Input position. So I assume this is gonna fail right now because at one point we probably don't have the model weights. Stream tokens. Let's see whether model has input path or something here. Guys, we're wrapping up soon, just FYI. Almost 6:30 p.m. I said that I'm stopping at 6:30. Need to stay on schedule because 11 hours of streaming today. That's gonna be like a ton of streaming. This is like 8 hour already. GPT pipe. I don't see batch size. Where is the? I don't know. Let's just try and run it. Okay, something happening or not? Okay, multiple processes. Batch is done. It did not fail, but let's see. Raw text empty generated. Okay, so apparently we got something, but it's gibberish, which means we probably just we made some error, but it did not crash, it just has incorrect output. It does look like English. At least the high level structure. The details kind of don't work, but hey. Okay. Message. Return logits. Append. How many times are we gonna do this until what? What is the stopping condition here? Broadcast, stream. I think let's just hit F5. Okay, guys. At least it did not fail. There is no crash. Let's see whether we get the output file. Okay, we get the output file. Here it is. So 10 samples, all of them are gibberish, but we are onto something. We've set up the environment. We managed to run the script after setting the 0 stage setting to 0, because we don't want to use 0 for such a small checkpoint. We'll probably have to download the checkpoint. We'll do step-by-step debugging later, probably tomorrow. Tonight we're gonna do, basically we're gonna go through the paper for the Korean large language model, and we're gonna also go through the Japanese blog, Japanese LLM. So that's it. I'm gonna stop the stream now. I'm gonna go do some workout and then go back. I'm gonna come back in like 2 hours. See you then, guys. Cheers. Let me end the stream.